This week we're going to get into one of the most beneficial areas of programming, and that's automating large tasks. What I'm about to go through is based on a real project that myself and Lucy Cotto, one of my graduate students, did last summer for Matt Johnson and Wildlife. They were looking at hunting pressure of owls, and Napa County did not have a very good land cover model, particularly one that classified savannas. So we spent quite a while processing 1 meter data for Napa County, including LIDAR, which is effectively a 1 meter DEM, and 1 meter NAPE data, photo data, to get the a 1 meter land cover model for Napa County, which is pretty cool and pretty incredible resolution. So we've got just a few of the hundreds of data files that I'm going to download here, and please download them. I've got them in a new folder for this lab, and if you take a look, these are pretty tiny tiles, and there's hundreds of these tiles. I forget the exact number, but it took us a couple weeks to process all of these to create these tiles, and then it took us months to come up with the process for how to classify these. I don't know how long it took us to run the whole thing. In fact, we did it at 3 meters, I believe, because it was taking so long to do the whole thing at 1 meter. But you'll get to do a piece of that processing, which is pretty cool. Okay, so let's get started. I'm on the batch processing learning module, and I'm going to go to the first web page here, and again, just copy and paste some code. Please read the web page when you have time. And what you'll see, probably pretty typical by now, you'll see we've got input path and output path. We're including the OS standard library because that's what we use to get a list of the files that are inside of a folder. So first things first, Windows puts this annoying parentheses with a 1 in it when it gets a duplicate download. So I'm going to get rid of that. Use our old shift, copy as path, paste that in for my input path, do what we do, change out slashes. Now, if you get tired of changing out slashes manually, you can just do a Control H and then go through and do. Whoops, not overdo though, too many slashes. Okay, and also I want to make sure there's slashes at the end. Okay, otherwise when we add a file name to it, we're going to have problems. Okay, the other thing we need is we need some place to put our final land cover. And this little subset we're going to do is we're going to classify just grass, shrubs, and trees. We're going to do it just based on height. Obviously that's not perfect, you'd get short trees, but we're going to do it just on height. And then you could use more sophisticated approaches to combine this with remote sensing and other methods. Okay, so if we take a look at what happens here, go ahead and run this. Whoops, oh, should set up my output path. Let me finish doing that. Whoops, shift, copy as path. We do this a lot. Control H, place. Oh, not up there. Okay, I'm going to do what I usually do. I do this. I was trying to show you the other way, which you can do, but I just do a lot of stuff manually. I find sometimes doing stuff manually takes less time than doing it in an automated way. Okay, land cover 2. All right. Go. Why didn't that work? Cannot find the path. Oh. See, when I do stuff too fast, I make mistakes. But I don't want to have this be a 2-hour video either, because I did spend a couple hours going through this first. Okay, so now we've got a list. Now what this does is when you give an input path, we say list directory, comes back with an array with the files that were in that folder. Okay, ta-da! So now we've got that. Now we can go into a for loop. Now, we haven't worked with for loops a lot. I don't use them a lot, but this is a natural place to use them. I tend to use while loops because they're more flexible, and as soon as you need an index into something, go to a while loop. But for loops allow you to say for the file in the list, and then it's going to go and repeat whatever's inside the for loop. Notice all this is tabbed in. It'll repeat everything in here for each entry in the list. First time we go in here, it's going to create a new variable called the file, put the first entry in the list in it. Then we'll come back, it'll go to the next entry in the list and the next one, and it'll exit when it's done with all the entries in the list. Okay, there's another OS function called split that's going to break up our file name and our file extension. Now, why are we doing that? Because you may notice I just put them right back together again with the file path. Well, the reason for that is because we want to look at the file extension and we only want to process .tiff files. The code on the web had .img, so let's change that to .tiff. And then I'm going to go ahead and run this, and I'll go ahead and pull the breakpoint now because I think it's going to work. And there it is. Found file to process, and it found all 4 of our TIFF files. Okay, so now probably want to do some processing. First, since I'm going to use SpaPy, I've got to go get some SpaPy code. And feel free to grab this out of code that you've written before. I tend to keep track of websites that I copy stuff from. And I tend to actually make websites that I copy stuff from. So that's kind of easy for me. Just go off and grab the websites that I built for class, which will stay up there, by the way. SpaPy is not going to go away. All right, now we've got SpaPy. We don't need the file paths because we've got our own. What we do need is we do need some stuff from the raster tutorials, specifically some raster math operations, because what we're going to do is we're going to go ahead and find, like for grass, we're going to find where the raster values are less than 1. In other words, for this file, we want to find out where, for our input file path, where are the values less than 1, and that is going to be our grass data set. Now that'll be Boolean, right? It'll be zeros where it's greater than or equal to 1, and 1s where it's less than 1, qualified as grass. And then let's go ahead and show that. Oops. I don't think we need this for now. And there it is. Okay, and you can see that we've got 1s where there's grass, these flat areas. That's probably some trees or shrubbery in the middle of it. We've got other areas that are grass, okay, and the rest of it is zeros where there's trees and shrubs or anything really 1 meter greater. Okay, so that was easy. Let's go ahead, oh, and it'll do it again once I stop it. Let's go ahead and do the same thing for trees. So for trees, we want to do greater than or equal to 3. So 3 meters, about 9 feet. And let's go ahead and show that one. And I do this progressively. Now, notice the areas where there was grass, it's black now. Okay, where there's trees are 1s now. All right, now, gets a little bit trickier because for shrubs, we want to find out where it's, let's see, let's first do greater than or equal to. I guess I would just do this, yeah. So this is greater than or equal to 1. Okay, so we're looking for something greater than or equal to 1, and we want to find something that is less than 3. Okay, so we've got to do this in 2 steps. Less than 3. Okay, we've got to do that in 2 steps. Because we're trying to find for shrubbery those things that are greater than or equal to 1 and less than 3. So it's 2 steps, and obviously it took a little bit of time to figure all this out, Lucy and I. So don't worry if it takes you a little bit of time to work this through when you do this type of problem for yourself. Okay, there's the tree one because I forgot to comment it out. All right, there's our one that is greater than or equal to 1. And you can see it's the opposite of the grass data, right? Instead of having 1s here where there's grass, it's now got 0s there and 1s everywhere else. Then, same thing for the trees. We've got 0s where we've got trees and 1s everywhere else, including the grass. So, we can now combine these and say that for the shrub data set, we want to find where we have something greater than or equal to 1 and less than 3. And that should show us where our shrubs are. Go ahead and comment these out. Ta-da! Notice the areas that are grass are still black, the areas where trees are still black, and the in-between stuff is our shrubbery. Okay, so now we want to combine these together. But what we've got is we've got 3 different data sets. Each one has 0s that is not the target species and 1s where the target species is, okay, or type of vegetation. So now we need to go ahead and combine those together. Well, to combine them together, we want to code them, right? And this is fairly typical for land cover data. Is like grass, we're just going to make it equal to 1. So we're just going to take grass times 1. And we're going to take shrubberies and multiply that times 2. And we're going to take trees and multiply that times 3. Whoops, what am I doing? Okay, there we go. All right, so that way we have unique numbers for each of our different types of vegetation, and then we can make our final land cover by adding these together. In other words, here we're going to end up with a data set that has 1s where there's grass, 0s everywhere else. This one will have 2s where there's shrubbery, 0s everywhere else. Trees will have 3s where there are trees, 0s everywhere else. Because of that, we can now go ahead and just add these together. Okay? And then we'll go ahead and show that. Check it out. I paused there because it's starting to take a little bit of time. And there we go. So now you can see we've got grass. And then oh, look, there's shrubbery here scattered throughout the grass, and then some trees. Shrubbery in here. Grass along these that kind of look like riparian areas. Okay, more grass. Cool. So it looks like our land cover is working. Go ahead and stop it or it will run forever. And then we want to save it. Now, where do we want to save it to? I'm going to go ahead and comment this out. Where we want to save it to is our output path, but we really want to have an output file path that's equal to our output path plus our file name and our extension. So we're going to call it the same thing, same file name, and that's why I've got these 2 different folders. Right, and this is, I mentioned earlier, this is kind of how I do a lot of processing, is I'll set up a folder for my inputs, set up a folder for my outputs, and especially if I'm doing a big data set over multiple processing steps, I'll set up multiple output paths and then go boom, 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 move it through one after the other. And this not only allows me to keep straight where things are, but if the processing is going to take a long time, I can process into one output path, let's say for the land cover, and then another one for the remote sensing data classification, something like NDVI, and then I can put those together into another one, and then I have one script to do each of those steps, so I don't waste a lot of time running things over and over again. Okay, then we go and run this, and now of course the really cool thing is I turned off show, our script is now running in the background, and there's our land covers. Now they don't look very good in Windows because Windows doesn't display things that only have 0s, 1s, 2s, and 3s in them. So you definitely want to load this into a GIS. And I've got QGIS up over here. So I could take and drag and drop one of those into there. And oh look, isn't this cool? I actually didn't do this when I was developing it. It's pretty neat. Oh, look at that. I bet those are vineyards. This is Napa County. So look, we've got trees, we've got shrubbery, but really those are vineyards, and then grass in between them. That's pretty cool. Have fun.